Hello and welcome back to another video. And in today's video, we're going to talk about a algorithm called selection sort, right? So what is a selection sort, right? Suppose you have an array like this, and the selection sort basically deals with selecting an element and pushing that min element to the left, right? As you saw in bubble sort, what happened in bubble sort? Let's have a quick recollection. So in bubble sort, what we did is push the largest element, okay, to the right. And how did we do that? By swapping. But in case of selection sort, what we're doing is essentially selecting one mid element, okay, and we're going to traverse and find the smallest element, and we're going to put it over here. And in a similar way, we're going to find for the rest of the items in that respective iterations. Didn't you understand? It's okay. I'm going to explain that in much more detail. So suppose you have an array like this. Okay. And let's say the elements were, okay, 5, 4, 1, 2, and 3, right? So then now the goal is to bring in the smallest elements to the left, right? So you'll have a number of iterations, just like bubble sort. It's as same as that, but the goal is to go about bringing the smallest element to the left, right? So now, starting from here, you're gonna keep this as your min element, and you're gonna swap that with the most least element. And again, so unlike bubble sort, you don't do like multiple swapping over here. You just do the swapping with the most min element, right? So we're going to consider this as to be our element, and then you start your iteration from here. Okay, 1, 2. So your min element so far is 4 lesser than 5. Yes, it is. So that's the minimum element. Is 1 lesser than 4, because so we're gonna have to maintain a min element. Okay, so that's usually gonna start with 5, and then once we go to 4, it becomes 4, and then once we go to 1, it becomes 1, right? And we go to 2, is 2 smaller than 1? No, it's not. And then we go to 3, and then we stop over there, because we can conclude that 1 is the smallest element out of this thing, and 1 is the number that has to be swapped with the number 5. So we have the swap that is going to happen after this, and what we're going to get is something like this: 1, 4, 5, 2, and 3. Okay, so this is what the array looks like after the first iteration, after 1, right? First iteration. So we did our first iteration over here, iteration, and now this is gonna have, oops. Okay, so this is our second iteration. So we know that this sort of thing is sorted, but we're gonna find it for this guy, right? The second guy. We need to find the second guy's correct position. Not his correct position, but the element that exists probably somewhere in this array. Okay, we're gonna find that number that deserves this position, which is this one, this index, the first index. Okay, so now we're gonna go on a search on our journey. We're gonna see which number fits this number, right? So is this smaller? Okay, now we're gonna maintain, again, as I said, a min number, which is gonna be 4 at the start, because we have to compare with 4, right? Min becomes 4, and then we're gonna compare that with 5. Is 5 smaller than 4? No, it's not. So we don't do anything. We'll go to the next number, which is 2. Is 2 smaller than 4? Definitely yes. So that's smaller. And we go to 3. Is 3 smaller than 2? No, it's not, right? So that is where we stop. And we now realize that 2 and 4 are to be swapped. So these guys get swapped, right? So what we have up next is something like this. We get a array, we have 1, we have 2, which was just recently swapped, and then we have 4, right? And then 3. Now, similar way, we know that these guys are sorted, but now we have to find the correct correct element that deserves this sort of index, right? This sort of position. So we're going to start our journey again. We're going to keep the min as to be 5 initially, okay, over here. But we're going to start our journey from here. We're going to compare that with min, this element. Is 4 smaller than 5? Yes, it is. So 4 is the min. And then we're going to go to the next one. Is 3 smaller than 4? Then yes, it is. So 3 is the smallest thing. So now what we do is go about, again, swapping, which is what we did all this time. So we swap again. Okay, so we're going to swap again, and we are going to get something like this. Okay, we're going to get something like this. 1, 2, 3, 4, and 5. Now, I know it's already sorted, but in not all cases would it have been sorted this way. So accordingly, according to our iteration, until here we had it sorted, and if we go to the next one, we're gonna have to start and look for this particular position, which was at 3. Who deserves index 3? And the min element, which is going to be set to 4 initially, and we're going to start a journey from 5 and also end it here because that's the only element that is left. Okay, so we're going to compare, is this smaller than 4, the min? Well, the answer is no, so it's not going to be swapped, and that is where this sort of iteration ends over here. Okay, and it's going to move again here, and we do nothing here because it's the last element and there's nothing to be compared itself with, right? So that was more about selection sort. So you basically have to select the single element, okay, from this place to this place and find the min element that deserves this particular position, right? So let's try to come up with the code of this, and then we'll try to think about the time complexity and so on, right? If you're still having confusions with time complexity, it's all right, it's okay. Over time, it actually helps you analyze and understand the time complexities, or come up with time complexities even better. It just takes time, you know? So what we did over here is we created a for loop, right? What color do you like? So we'll start with I is equal to 0 to n minus 1. So I'm going to set the first element as to be my key. So this is what we do in a selection sort. So we're going to make one key, which, like we did over here. This is our key, this is our key, and in this case, do you guys like prefer better colors? Okay, this is our key, and in this case, this is our key, right? So our key is basically going to be array of I, right? And oops, I think you also have to maintain. Well, anyways, let's that is our key. Yeah, you also have to maintain the index of it. The reason why, I'm going to tell that later, but it's important because we're going to swap it as well, right? So we've already dealt with creating swap functions. So this is, as I said, this part of the code deals with swapping, right? So that is where we'll have to define swap, right? And if you don't know how to do that, please look into the previous videos. It's okay, I'm going to explain that again in this video as well. So anyways, so this is what we did. We stored the key and also the index of this, right? So now we're going to create another for loop starting off with j, which is equal to I plus 1, right? So every single time where I was over here, we always started with j being I plus, like immediately after that, right? So j lesser than n, okay? So there, I mean, there are places where it cannot land to, but if you were to deal with some certain edge cases, that is where you're gonna have to optimize that, or maybe it just doesn't matter because it wouldn't just even, j wouldn't even go there, or I for that matter, right? Okay, so in this case, what we're gonna do is we're gonna go about comparing if array of j is lesser than key. Okay, if that is true, then key is gonna be array of j. Okay, you know what this means? This is an assignment operator. That means the key value keeps getting changed, right? So every single time array of j in this sort of iteration over here is going, like as I said, it becomes 5. Oops, yeah, it became from 5, it went to 4, and then it went to 1, right? This key is equal to array of j, because array of j was lesser than key. Okay, I don't know how more dumber to be to explain this, but I hope you guys understand what I'm saying, right? So key is equal to array of j, and also you have to update the minimum index, right? So the minimum index was I initially, so the minimum index now is going to be j, because that array of j was lesser than key apparently, right? So min I, okay, I think we're gonna save it as min key instead, the variable, because it's much more understandable. And then that would be j. Okay, so once we're done with this sort of for loop, what we're gonna do is swap array of items starting with I and also j. Oops, it's not I, it's min k, sorry, min key, oops, okay, wait, it should have been I and min key, right? This is the min key's index. Yep, so, and that is where you end your for loop, right? Okay, so that is where you end your for loop, and this is where the swap operation happens, and it goes to the next iteration in this one. Okay, so, and you also have to define swap here. So if you still don't understand, it's okay. We're gonna go try to debug and try to understand things, right? So what happens in the swap function over here? Okay, so let's talk about that. So we know we have to pass an array, we have to pass an integer, which is going to be index int a, int b. Okay, we're going to try to deal with that, just that. Okay, so this is going to be a void function because it does not return anything. I mean, it just depends on your use case. You can modify anything to however you want it, right? So now you're going to maintain a int temporary variable, and that is going to be array of a, and array of a is going to be array of b, right? This is what was explained in the last video of bubble sort. If you have not watched that, please watch it. And this is how the temp variable is used, just so that you can store one of the variables before you actually put in assign variables between a and b's index. Okay, this is array of a and array of b. So just saying, okay, just in case if you're a very beginner, array of a and okay, I don't even want to use this, and even this and actually means a Python operator. Okay, just saying, array of A and A, both of them are different. Okay, so you might be like, hey, I did go about doing A plus B, A greater than B, and have this sort of condition, but it didn't work. Well, because your stupid brain thought array of A and A was the same. It was not, right? So, I mean, it's okay to be stupid. You know, we're all stupid sometimes, and it's okay to accept that. So, well, okay, so we're going to be coding that sort of thing, and this is Strivish A to Z sheet, and I highly recommend this because this is a really good collection of problems that you can actually solve. So where were we? We were in this. So we, according to our playlist, we have so far finished bubble sort. We have just learned how to do selection sort, and well, what did we learn today, right? Selection sort, we have to basically go about selecting. Okay, so we're gonna have to go across over here and from here, here, and then go about selecting the minimum element and then swapping that. So in our case, in the first iteration, 1 is being swapped with 8 and so on and so forth. We find in the second iteration that 2 is the smallest element, and in the third iteration that 5 is the smallest element, and so on and so forth. So how do we do that, right? So now this is a void function, so it doesn't return anything. So you don't have to return anything, right? So we're gonna go about finding the length. This is what I always go about doing. I might find it handy at certain times, right? So what I'm gonna do is create a for loop. I is equal to 0. That's where I is gonna start from, and I is less than n and I plus plus, right? So, all right, and then I'm gonna go about maintaining a variable called key, which is array of I. And also I'm gonna maintain key index, which is array of, sorry, this is just I, that is the index, right? So key is basically the element that is the smallest, and it is gonna be swapped with I. That is, in this case, it would be swapped with 8. And we're going to have to find and update key and key index, right? So we're going to have a for loop starting from I plus 1, and j is going to be lesser than n, j plus plus, and you're going to see if array of j is, let's just say, smaller than key, then what we're going to do is update the key to be this, and also update key index to be j, right? And now, after this for loop, this whole loop, you will have the smallest key value and its corresponding index that is going to be updated, right? So now what you're going to do is basically go about swapping it, and you're going to pass in your array, and you're also going to pass the corresponding indices that have to be swapped. The first thing is I, and the other thing is key index. Okay, mind you that you can actually name anything you want. We did not define our swap function yet, so we're going to do that, just that. So we're going to create public static void swap, and that is going to be int array, int a, int b. All right, and now we're going to go about swapping it. We're going to use that a temp variable, and we're going to use another element here, and then swap it back all, right? So that is our swap. I like to hide things out so that I can see the whole picture. Right, looks good to me so far, but might be okay. So there were no mistakes, and right, so it was able to accept this sort of solution. So let's talk about the time complexity of this. Let's choose a good pen, you know. So what we did was we used a for loop. Okay, wait. Let's try to get closer. Okay. Okay, so what do we do in this thing? So we used a for loop, which costed us n iterations, okay? And also in each iteration, we went about doing these number of iterations so that we actually did all these comparisons over here. So what we did is essentially we went from let's calculate the time complexity. We went from 0 to n minus 1, right? And in the other iteration, which is inside the for loop, if there is something that happens in every one of these iterations, so you'll have to multiply it. That's how things are, you know? And if that was the case, then it was n minus I plus 1. Okay, so what is I? I is basically like 1, which keeps getting incremented, okay, over time. So, okay, so if you were to just calculate that, if 0 to n is around n, and also this number basically would just, let's just say it decreases over time, and it's basically like this, right? You have this, and the number of iterations that goes around is around like this, right? For the I iterations. If this is, sorry, for the j iterations. For if this is I that moves these number of iterations 0 to n minus 1, right? And right, so we have around n number of iterations, and in case of okay, something is really wrong. Okay, and needs to be fixed. Okay, in the case of j, it keeps on decreasing as i's value gets increasing, because j is going to start from I plus 1, right? So essentially you will have something like this, right? So it's around n by 2, okay? So we can say it's going to be somewhere around n squared by 2, and the time complexity is around n squared, because we don't really care of if it's divided by 2 or 3, as long as it's nowhere close to n. Okay, so the time complexity is n. This is the worst case, this is the best case, and this is also the average case, because it's the worst case because you know, it travels n squared by 2. And the best case, because even if it's swapped correctly, like bubble sort, it would still go about checking it and making sure that if the smallest element is in its correct position. So technically, you'd rather use bubble sort if you care about time, you know? And if it was already swapped, maybe the bubble sort would at least stop, right? So that was it for today's video, and this was about selection sort. And in next video, we're going to discuss about insertion sort. Okay.